Welcome back to Algebra. We're going to continue adding and subtracting polynomials. These problems just look a little bit harder, but really when you get the hang of it, they're not any harder at all. So if we have, for instance, 2x squared minus 3x minus 4, and then we're going to add to that another polynomial, 3x squared plus 4x minus 6. All right, so you can rewrite everything and drop the parentheses if it helps you. You definitely don't have to do it, but let's just go ahead and do it in this case. So what we have is 2x squared minus 3x minus 4 plus 3x squared plus 4x minus 6. So the reason we can drop the parentheses is because we can't really add anything here. So we're basically done. So we drop it, and we're just basically adding this, and we start looking for like terms. The only thing you really need to know is that like terms in the previous problems just involved a single variable like x or t or something like that. But here we have an x squared, and here we have another 3x squared, or I should say 2x squared and 3x squared. So these are actually like terms because x squared is exactly matches another x squared there. Let me ask you a question. Do you think these two guys would be like terms? Well, they both involve x, but are they like terms? The answer is no. In order for something in algebra to be a like term, all of the variables must match, and all of the exponents must exactly match. If they don't exactly match, it's not a like term. So you have to be talking about the same variable and the same exponent. So this is a like term with this. The negative 3x is a like term with the 4x. But for instance, these two terms are not like terms. So now that you know that, let's start hunting. We have a like term here. So we have a positive 2, positive 3, which means it's going to be positive 5. And you have to carry the variable, and you have to carry the exponent through, so 5x squared. And we'll put a little dot here just to remind ourselves that we've already looked at those. And now we look for other like terms. We have negative 3x, we have positive 4x. Those are like terms. So negative 3 plus 4 is the same as 4 minus 3, so that's going to give you 1, and it's an x, so it's going to be 1x. So we'll just write it as x. Like that, and we'll put a little dot here just to remind yourself that you've looked at those. And so then we'll just look, now we have a negative 4 and a negative 6. How do you do that? We've added negative numbers or subtracted negative numbers like this quite a bit, so you add them. 6 plus 4 is 10, it's going to be negative 10 because you have negative 4 and you're subtracting even more from it, so it goes more negative like that. So the answer is 5x squared plus x minus 10. So it's the same thing we've been doing before. We're just hunting for like terms. It's just now we have to be a little more careful about how we choose what the like terms are and make sure we're correct. Let's say we have 3n squared plus 5n minus 6, and we're going to add to that another trinomial, negative n squared minus 3n plus 3. So you see what we have here. This is not a like term with this, so we cannot combine them or add them. Of course, we can't do anything there either. Same thing here. These are not like terms, so we can just drop the parentheses, and that helps us visualize what to do. 3n squared plus 5n minus 6. Now here you have to be a little careful. You're adding a negative n squared, so you write it as minus n squared. Same thing here. You're adding a negative 3n, so it's just written as minus 3n, and then you have plus 3. Now we start looking for like terms. We have a 3n squared. What is a like term with that? Obviously it's not this. Obviously it's not this. It has to match exactly. So we have an n squared here and an n squared here, so those are like terms. So 3 minus 1, that's how you read that. 3 minus 1 is 2, so it's going to be 2n squared. And we'll put a dot here to show that we've looked at these guys. Now, we continue looking. This 5n is a like term with this. So you have 5 minus 3. So 5 minus 3 is positive 2. Positive 2 what? It's going to be positive 2n because that's the variable that you're adding there. 5n's minus 3n's is going to give you 2n. And then finally, you look at the last thing. You have negative 6 and you have positive 3. We've done enough of this. You should know that that's now negative 3. All right, and that's the final answer, 2n squared plus 2n minus 3. Only difference is we just have square terms, or you might even have higher power terms. We'll get to a problem like that in a little bit. You're just hunting around for like terms. So now you have, for this problem, 3x squared minus 4x minus 2, and we're subtracting from that a polynomial negative x squared minus 4x plus 7. Now here you have to be careful, you have this minus sign, so you're going to have to distribute that minus in as we write everything down. So first we can drop the parentheses, 3x squared minus 4x minus 2. And then we distribute the negative in here, that makes it a positive x squared. And we distribute this in here, that makes it a positive 4x. And we distribute this in here, that makes it a negative 7. And now we start looking for like terms. So we have a 3x squared and a positive 1x squared. So 3 plus 1 is 4, so that's going to give you 4x squared. And we'll just put a dot to remind us that we've looked at those. And now we will look, we have negative 4 and positive 4. So, and these are like terms because they involve x just by itself, x to the first power. So because they're negative 4 and positive 4, we can just strike through them. They're going to add to 0. They're not going to really contribute anything. So then we look at negative 2 and negative 7. We've done enough subtraction, you should know that's negative 9. If that's confusing to you why it's negative 9, go back and review all the lessons we did on adding and subtracting negative and positive numbers. So the answer to this one is 4x squared minus 9. So you see the like terms have to have the variable with exactly the same exponent. Here we have a square and here we have a first degree, but you're going to find out that you can have higher powers as well, but the same rule applies, so it's pretty easy. For instance, if you're adding together u to the third power minus 3u squared times v plus 2uv squared, and we're adding to that another trinomial, 3u squared v minus 2uv squared minus v to the third power. How do we handle this? Okay, now first of all, I want to point out that we have a trinomial here. I want to talk about like terms. This guy is u to the third power. This is u squared v. So when we talk about like terms, every variable has to match. Okay, every variable and every exponent has to match. So these are not like terms because they don't match. These look totally different than what this variable is. This is u to the third power, and this is u times v to the second power, so none of these are like terms, so we can't add them together. Same thing is true here. None of these are like terms. Now here you have a plus sign, so really what you would do is distribute the plus in. It's not going to change the sign of any of these things, so really you can kind of mentally just drop the parentheses here, and I'm not going to make you rewrite everything all the time, so we don't need to rewrite this out again since it's just plus. We can just start looking for like terms. So first, let's go figure out if there are any like terms that match with u to the third power. So we need to find a term that just has u to the third power, nothing else. This one doesn't have that, this one doesn't have that, this one's not u to the third, this one's not u to the third, this is v to the third, that's not u to the third. So there are no other like terms that match with this. So when you're adding it, he's just basically going to come down as part of the answer. So it's going to be u to the third power, basically plus nothing else, so he just comes down. And we'll put a little dot here to show us that we've looked at this. All right, then we look for anything that matches u squared v. Now this is v times u squared, so this is close but not quite. We're looking for u squared v. Here is a u squared v. So this is correct, u squared v. So this is positive 3, but this is negative 3. So what's going to end up happening is this is going to subtract out. These are like terms. Those two things are like terms, but 3 minus 3 is 0, or in this case it's just negative 3 plus positive 3 is 0, so they just divide away. So now we look at this third term. Here we have u times v squared. We look over here, we see a u times a v squared. So these are like terms. They have exactly the same variables and exactly the same exponents attached to those variables. But it's positive 2 plus a negative 2. So they're going to basically add out to 0. So you can kind of strike through those. And then finally we look through. The only thing left is v cubed. There's no v cubed, so he just comes along for the ride. Now there's a negative sign there. So you need to write it as minus v cubed. So the answer is actually u cubed minus v cubed. And most of these terms actually just subtracted away. All right, let's do one more here. What if we have 3a cubed minus 2ab squared minus a cubed minus 4ab squared minus b cubed. Now, because we have a polynomial and we're subtracting another polynomial, we have a minus sign here, so this needs to be distributed in. It's going to change the signs of all of those things. So it's better just to go ahead and write everything down again. 3a squared minus 2ab squared. Then this is going to become a minus a cubed plus 4ab squared plus b cubed. Make sure you understand, basically this made it negative, this made this positive, and this, because it's negative times negative, made this positive. Now we can start hunting for, and actually I made one mistake when I wrote down here, this guy is actually cubed. So this is just a mistake in my writing here. Okay, so we have 3a cubed. Do we have any other a cubes? We have an a cubed right here. So we have 3 minus 1 is going to give you 2a cubed. And we'll put a little dot here to signify that we've looked at those things. Now we go back and look and say, do we have any ab squareds? Well, we have an ab squared here. These exactly match. A matches, b squared matches. So we have a negative 2, positive 4, which is the same as 4 minus 2. And so what you end up with is positive 2ab squared. Make sure you understand that. Okay, and we will put a dot underneath both of them showing that we have looked at them. Now the only term left is this b cubed here. There's nothing to add it to, so we will just say plus b cubed. So the answer is 2a squared plus 2ab squared plus b cubed, and that's the final answer. So make sure you understand this. You're just looking for like terms. The variables have to match in order to make them like. So in this case, a and b match, but the exponent has to match also. If this exponent was at 1 or a 3 here, then these would not be like terms. And then once you find like terms, you can add them together and simplify the result. So make sure you follow, make sure you can do this and understand the concept, and follow me on to the next section. We'll continue learning all of these skills step by step in algebra.